Hello, today we're going to look at section 1.3, the zero and negative exponents. I hope that by the end of this lesson you're able to explain what a power with an exponent of 0 is equivalent to. I hope that you can rewrite powers with a negative exponent to have a positive one, and that you can demonstrate what powers with negative exponents represent. First off, I have given you a couple patterns to look at. So complete the following patterns and see if you can make some generalizations about powers with a 0 exponent and a negative exponent. So look at the pattern here, see what's happening, predict what you think will go in the following blanks on both of these patterns, and then look for any similarities and see if you can come up with some generalizations. Pause the video here and give that a try. Okay, let's check your predictions to see how things went. When I look at this first one here, 10 to the power of 4, I get 10,000. And as we move down a power of 10, if I think about that in terms of repeated multiplication, I'm multiplying by 10 one less time. So that would be similar to dividing by 10. So to go from 10,000 down to 1,000, I would divide by 10. Let's see if that pattern continues. If I divide by 10, I get 100. Perfect. And that makes sense because I have one less factor of 10 multiplying. And I can carry that on down here. 100 divided by 10 gives me 10. So a prediction might be, will this pattern continue? Or this pattern does continue, and let's see what happens. 10 divided by 10 is 1. Okay, and if we carry that on a little further, 1 divided by 10 is the same as 1/10. And if we divide that by 10 again, we get 1/100th. And if we divide by 10 again, we get 1/1000th. Okay, let's compare that pattern to the one on the right. Here, from 81 down to 27, we're dividing by 3. And we can see that because we have one less factor of 3. In the first one we have 3 to the power of 4, so 3 times 3 times 3 times 3. And the next one we only have 3 3's. So we've divided by 3 to go from 81 down to 27. And that will continue on and continue on. So it's true for all of these first values that we have divided by 3 each time. So we could predict that that is also true for the next one. 3 divided by 3 is 1. And if we continue on, 1 divided by 3 is 1/3. 1/3 divided by 3 will be 1/9. And 1/9 divided by 3 will be 1/27th. So I don't know if anything is jumping out at you yet, but if we first look at the 0 exponents, we can see that they are both equal to 1. So it doesn't seem to matter what the base is. As long as the exponent is 0, our value for the power will come out as 1. If we look at the negative values, we can see something interesting happening. In the first one we have 1/10, nothing too crazy there. This 10 is to the power of 1 even though there's not a 1 written. 1/100 can be rewritten as 1/10 squared. And 1/1000 can be written as 1/10 to the power of 3. So if we start to compare the exponents that we have in these two values, you can see that they're almost the same. The only difference is that when we have a negative exponent, we end up with a positive exponent. So 10 to the power of -1 is equivalent to 1/10 to the power of 1. And 10 to the power of -2 is equivalent to 1/10 to the power of +2. And this carries on. So that gives you a little bit of an idea of what negative exponents look like. Let's check that out on the value of 3. So 1/3 is the same as 1/3 to the power of 1. 1/9 is equivalent to 1/3 times 3, or 3 squared. And 1 over 27 is the same as 1 over 3 cubed. So the pattern holds true here as well. So whenever we have a negative exponent, we can rewrite it as 1 over the same base, but change the exponent to be positive. So a little bit of a summary. The value of any power when the base is raised to a power of 0 is 1. So it doesn't matter what the value is here for a. If you have an exponent of 0, the power becomes 1. So go ahead, pause the video here and take a moment to answer the questions for 16. Okay, hopefully you've had a chance to give these a try on your own. 6 to the power of 0 will be 1. Negative 9 to the power of 0, 1. The negative of 9 to the power of 0. Well, the negative is not included in the base here. So I know that I have this negative of 9 to the power of 0, and 9 to the power of 0 is 1. So this actually simplifies to be negative 1. And over here, I can see that the 0 exponent is acting on this 6 squared. So I have 2 times 6 squared to the power of 0. This piece here will become 1. And 2 times 1 will give you 2. So that's the 0 exponent. Let's look at the negative exponents. A non-zero base raised to a negative exponent has the following properties. So any non-zero base, any non-zero value for a, when it's raised to a negative exponent, negative value of whatever the exponent is, we can rewrite that as 1 over the same base, but change the exponent here to be positive. 1 over a to the power of n. And therefore, if we go in the opposite direction, if we already have 1 over some base with a negative exponent, we can flip that fraction and rewrite it with the same base but change the exponent to be positive. So those two are opposites, and I'll give you a chance here to pause it and give 17 a go. Okay, check your work here for 17. X to the power of negative 3. Okay, I want to rewrite that with a positive exponent, so we have 1 over x to the power of positive 3. Y to the power of negative 9 will be 1 over y to the 9th. And 4 to the power of negative 1 is 1 over 4. I can write the power of 1 up here, but I don't really need to. And next, 1 over a to the power of negative 5. Well, we can flip the fraction here and rewrite this as a to the power of positive 5. And if we were given a to the power of positive 5, we know that we could rewrite it as 1 over a to the power of negative 5. For the last one here, we have y and x to the power of negative 2. I can rewrite this one as y times 1 over x to the power of negative 2. And you can see now if I separate those two pieces, the y doesn't change. But 1 over x to the power of negative 2 is is x squared. So there you go. Go ahead and give the practice questions a try.